Welcome to my webpage where I describe data acquisition with just simple, ordinary C++ software. You have to trust yourself. If you've gone through part one, you understand it. You have like 95% of what you need to do to complete part two. Just trust yourself with a little bit of work. You can do it. In part one, I discussed the controller software. That was the software to GPIB, RS-232, or Ethernet. In part two, which is the video you're watching now, what I will discuss is the signal generator. That's the device or equipment that applies a signal to your device under test, and also the equipment that collects the response from your device under test. As promised, there's some free software available. I basically gave you this PowerPoint presentation and a C++ project available for free download. Just go to my webpage, the address is below, and download the software. The expected audience will have a knowledge of the C language. If you went through part one and you were okay with that, then you have everything you need. But if you don't, then you can just well, you just need maybe around like a 9-week course. I don't expect you to know a lot. When I was in school, they dive down all sorts of rat holes in the C language. You don't need very much. You need to have the Microsoft C++ Development Studio installed. That's from part one. And very basic engineering knowledge. If you need to do data acquisition, you need to know what's measured, then you have everything that you need. Also, again, I'm going to say you need to complete part one of the controller code tutorial because I'm going to go over some stuff very quickly. I'm not going to dwell upon something I covered before. You need to go to my webpage and again, I showed you the address of where it is and download the software project. You unzip it to like a known location wherever you want and unzip it and double click on the .sln icon. Just see, I actually show it to you right here in the graphic. You will also need to have like a piece of equipment. It can be GPIB, Ethernet, RS-232, or RS-485. You need like a controller hardware for that, and a piece of a test equipment designed for your controller device. In the tutorial the following, I'm actually going to discuss GPIB, actually USB to GPIB, because it's the easiest to use. And I'm also going to use Agilent equipment because Agilent equipment has some of the best documentation that I've ever seen for data acquisition. What I'm going to actually show you on this tutorial is the combination of a GPIB USB and an Agilent meter that I believe I mentioned before. Other combinations are possible. Just contact me on my contact on my webpage. Enough people do this, and I will see what I can do. I mean, just contact me if you want another combination. The reason why I'm showing you these two pieces of equipment, the GPIB USB and the Agilent meter, is because they are extremely easy to use. The documentation is fantastic. I recommend you, if you're just starting on the road, yes, bite the bullet and buy an Agilent 34401A. These meters measure current and voltage, but the big deal about it is the documentation is fantastic. They actually have GPIB and RS-232 on the back of the machine. You can't see it on this picture, but they have both. And as I said before, they're fantastically easy to use. You're going to have to poke the equipment. I'm not going to go through the manual. You can do it. Look it up yourself. You have to poke the faceplate on the equipment. It's like the blue button plus a couple of other things. And you need to adjust the GPIB address. And for this example, I'm saying adjust it to 22. Yes, it's frustrating the first few times you do this, but welcome to the club. You can use RS-232, but just for this example, I'm using GPIB. When you open up the project, you have to click on the header files folder then click on the Agilent 34401A GPIB header file, and you'll see something like what you see on the screen here. You have to do this because I'm going to describe essentially 4 different functions, actually about 3 here. Right now, I want you to look at the Agilent, I call it the device discovery. What you see in the arrow here is that Agilent 34401 GPIB INIT. This is the initialization. This was covered in part by the first tutorial, part 1. But I want you to go and click on that and just go find the definition of it. It's actually just at the bottom of this text file. If you don't know how to search for it, just scroll down. Okay, now I take it. This is a review of what I've talked a lot about in the first part of the tutorial, part 1. But this is what I call device discovery. There's a lot of ways of doing it, but I recommend that you use the functions that I've given you. What you do is you execute, right here it's commented out, you execute that device discovery, and you should see that your GPIB equipment, information will pop up on a text file. You actually have to copy that text string into this function. And it's like GPIB, I can't see it here. Let's see, GPIB 022 : INSTR. You will paste the results inside of this function. What this function says is that this is the equipment I want to talk to. Okay, now I want to talk a little bit about transmit and receive functions. You can look at this, but the big picture is that these are what I call wrapper functions. It's almost like a shell. What they do is you take like a line of text, and you're going to send this to a function for any transmission to your GPIB device. And the same thing applies for receive. Why you do that, why you organize things like this, is that you may not want to use a GPIB. You could be using Ethernet, or you could be using RS-232. When you use a wrapper function like this, it's like procedural abstraction. I'm not Mr. Software Guy. I don't know all the lexicon. But it's what I call procedural abstraction. So you can easily adjust which interface that you want to use. You don't have to tediously go through like 30 or 40 functions to change it. You don't do it. You only have 2 places where you have to change things. This is very valuable if you want to switch interfaces. Now, this is actually the toughest. This is the last big hurdle in your data acquisition career, that, as far as using C language and what I've given you. This is the most frustrating thing that always happens at what I call proof of life. By that, I mean you want to talk to a piece of equipment. You can't just immediately launch into your whatever it is that you want to measure or automate. You have to have the initial connection, the initial contact, and I call this proof of life. The problem is that you have a lot of things that could go wrong, and this is just like the last big hurdle. Once you make it through here, you're in good shape. You have to go through 3 different parts: device discovery, apply device discovery results. I've showed you that in the previous slide. And here again, I'm saying proof of life is the most painful part. I mean, you can do it. You just simply have to beat on it. And why is this so painful? There are 4 things that all have to work perfectly for the communication to work. The conduit controller software, that's what I gave you from ANSI-C.com. The conduit controller hardware, this is what you purchased. It's GPIB, RS-232, or like some sort of Ethernet card. It could be like the port or something. The equipment driver, this is the software I just showed you. You have to adjust whatever text strings you send and how you receive them. And the equipment hardware interface, by that I mean inside of each piece of equipment you either have some RS-232, an Ethernet card, or GPIB actually on your equipment. It's what you connect to. There's some hardware inside. If that's fried, then your equipment won't work. And so this is just something where you're dealing with unknowns. So like practice some Zen meditation with perfume and soft music. Yes, this is frustrating, but once you make it past here, you're in good shape. There's a couple of tactics that you can actually use to minimize some of the stress associated with the proof of life. One of them is that sometimes like an equipment vendor will send you some demonstration software. It's usually crappy stuff that'll demonstrate some functionality, and you generally can't use that software for your application, or it's very painful. Uh, what you do is you set that up exactly like whatever the guide they have, and if you establish communication, what you've done is you have verified 3 out of the 4 things work. You know that your equipment works. You know the RS-232 or GPIB works. You know that the firmware inside of the equipment works. And the only thing that's an unknown then is the actual C code that you're writing. There's another way if you don't have that. Sometimes you have like an equipment that comes out of a known working good setup, and that way you know the equipment is actually working. You just have to think of things in that, like what those 4 variables can I eliminate? I'm not perfect, but this software I gave you, I've worked with it for approximately 12 years with no detectable flaws. If you find something, then email me. This is the controller software, all the different controller software that comes with part 1 and part 2. The biggest source of problems are actually in the equipment documentation and or the equipment's firmware interface. Your best bet is to find the simplest possible like message you send to it, like hello, how you doing, and and then a response comes back. You want to have like the simplest one that you can find. Don't try to like launch right into something big. Look for the simplest one. It doesn't matter what it is, as long as your equipment is not damaged or doesn't do something stupid like screw up some calibration. You want to find the simplest phrase that you send to it. You have to look through the equipment documentation. And the one thing I will warn you about, when they have like RS-232 devices, like equipment with RS-232 devices, are cheap and easy. And in general, uh, the documentation of how it's written and how it's formulated, those generally are not the best. The absolute best are the ones where you have an Ethernet with that port in the back. This is my general observation. The documentation is generally the best for that. GPIB is second in terms of like good documentation. That's the reason why I love Agilent so much. Boy, you can download all sorts of good stuff. So just be aware that this is frustration. There's no easy way around it. The good news is once you make it past this, you're there. You're set. And the initialization function, like proof of life, I can say it again, it's the worst part of data acquisition. And I recommend Agilent equipment because Agilent has fantastic documentation. What is more, GPIB or the NI 488 standard has a very simple command response pair. The command is *.idn !n. \n just means carriage return. And the response is something like Hewlett Packard 3441A. Depending on what your model is, when it's made, this message changes. But the big deal is that you send out a command and a message comes back. As long as it's intelligible, that is your goal. Don't worry about, like, this is not useful. Blah. No, it is useful. It tells you your software, everything is working. This is like very important. And you can look for through your equipment, but you're going to look for the simplest command response pair. There's other strategies you can use for debugging. When you send out a command and it comes back, what you can do, you can count the number of bytes and the return response. In general, if it's less than 2 bytes, then it's just garbage. Either the equipment, there's something in your setup is messed up, either your command or your equipment. But if it's less than 2 bytes, then problems. That's another way of testing for it. This is frustration. It doesn't matter what interface you use, you always fight this battle. And other places to look for bugs. Is there unnecessary white space in your command? Be careful where you put the carriage return or line termination. They have different themes. You can either \R, which is like I forgot, one of them's a line feed, the other one's a carriage return. But \0 is a special character. It means null. You have to look inside your product documentation. You might have to experiment. But these are the three things that, especially in RS-232, the dingbats don't realize that you need this information. A lot of times I just simply had to find this empirically. But line termination is another one where you have trouble. And the other one, the last one, is latency. Did you wait long enough for the response? If you send out a command and you expect it back within, 5 femtoseconds, it's not going to happen. Somewhere inside of the code that I've given you, you can adjust your latency, at least for the first part of this. Set your latency really big, like a half a second, or maybe even a second. I know it's aggravating, but you only have to do this in the beginning. Once you have proof of life, you can cut this down. But set your latency fairly big. In other words, you give it a command, and you're giving the little dingbat time to derby and answer you. And now you must be wondering, I want to do data acquisition. I have the proof of life, but where's the acquisition code? Yeah, that's what I was thinking a long time ago. If you've completed the proof of life concept on previous slides, you're essentially 99.9% of the way done. The rest of it is just finding crap in the manual you want and filling in the spaces. The project that I've given you, I've actually fleshed out basically all it does is just measure voltage off of an Agilent meter and just reports it to a text file. I've given you some other functions inside of there. If you have trouble with these functions, you need help, you know what to do, contact me. But once you have the proof of life concept in your previous slides, then you're 99.9% done. And what about the actual data acquisition code? You have to download the manual for Agilent's 34401A meter. It's available on the internet. It's almost in the public domain. There's a lot of them. Look through the code for that I've given you. That's from ANSI-C.com. Find an interesting function, like I picked AC current measurement. Look for in the manual for the syntax of the AC current measurements. And if you look at the manual and you look what I've done, then you see how I've put things together. You can do this for just about any of the other functions that you want to inside the manual. If steps 4 and 5 make sense, then you're ready to begin programming. I mean, that's it. You're ready. You're off to the races. There's other functions inside of this code. I think it's beyond the scope of this simple tutorial. Actually, this isn't simple, but this tutorial for me to discuss. If you want help with that, contact me. If you've gone through this and things are working for you, then you have the benefit of more than 16 years of test engineering. And the reason why I want to give it out, I absolutely hate LabVIEW. I really do. And you have the freedom from the abomination as LabVIEW. Yeah, sometimes you're going to have to fight with the manager and some dingbat who wants, oh, I saw it on the YouTube. It looks so good. You have to deal with that, but that's a personal battle between whoever dingbat calls himself your manager. Most managers that I've worked with, they don't care. They just want the job done, but occasionally you run into a dingaling that insists upon doing things their way, even though they don't have to do it. The reason why I say this, I want you to succeed and I want you to be happy in your job. That's the real motivation for these YouTube videos. I want you to succeed. No one helped me when I was there, and now I'm giving you help. Yes, it's going to be some work to do this, but once you do this, you have the freedom to do whatever you want in the laboratory. If you need more help, contact me via the contact page on ANSI-C.com. If you want other features and combinations, use the YouTube comment selections below, or sections below. Basically, the one reason why I want you to put some comments inside of there, it helps the search engine results. That's the only real benefit to me. I am not going to make a big fortune of like, subscribe, see next week's cat video. I'm not going to make any money off of that. I just want you to succeed. And if you need help, contact me via the contact page.